Hello students, in previous lectures we have discussed about magnetic flux and Faraday's law of electromagnetic induction. Now in this class we will discuss the numericals based on magnetic flux and electromagnetic induction. So I hope that you know the formula of magnetic flux. Now let's start. The magnetic flux through a coil perpendicular to the plane is phi is equal to 5t cube 4t square 2t minus 5 Weber. Calculate the induced current through the coil at t is equal to 2 seconds if the resistance of the coil is 5 ohm. Now we all know that by Faraday's law of electromagnetic induction, magnitude of induced EMF is E is equal to d phi by dt. So put the value of phi and take its derivative d by dt. And we have taken magnitude. So I think that you all know how to take derivation. So take this power downward, multiplied by 5. 5 3 is the 15. Reduce this power by 1, t square. Then multiply this power by this one, 4 to the 8, and reduce the power by 1. And again, same process. It will be 2. So E is equal to 15t square 8t plus 2. Now, time is given 2 seconds. So put the value of t is equal to 2 seconds. Then E is equal to 60 plus 16 plus 2 is equal to 78 volt. This is induced EMF. To find induced current, we should use the formula V is equal to IR. So I is equal to E by R. E by R. So I is equal to E by R. 78 by 5 is equal to 15.6 ampere. This is the simplest form numerical which can be asked from the change of magnetic flux. Now change of magnetic flux can be of many types. For example, now numerical number 2. Here change of magnetic flux is due to rotation of the coil. There was flux changing, but here flux change is due to rotation of the coil. So let us see how this numerical will be solved. This type of numerical will be solved. Find the average induced EMF in the coil if it rotates 45 degree in 0.4 second. Find average induced current and its direction in the given figure. So this is the figure. It is given that this is the magnetic field going outward, coming outward. This is the magnetic field coming outward, and this is a coil, and this is conducting coil. This coil is rotating. When coil rotates, then what will happen? Because it rotates, making an angle 45 degree. So we will see if it is at 0 degree, if it is at 45 degree. What is the change in flux? Delta phi upon delta t. This time we will use this formula, delta phi upon delta t. Delta final minus delta initial divided by delta t. So phi I is equal to B dot A. B A cos 0 and B A cos 45. Area is same. Cos 0 is 1. Cos 45 is 1 by root 2. Now we know initial flux. We know final flux. So we will subtract it and divide it by the time, which is 0.4 second. So in this formula, this calculation part is easy. No problem. Because directly we can subtract this, we can get the value. Now the part which is important is to find the direction of induced current. Now we see that here flux is decreasing. What is happening? By rotation of the coil, flux is decreasing. This is important point. Now flux is decreasing, then as per Lenge's law, flux should be opposed. In decrease in flux should be opposed. flux is decreasing means now already our field is on this side and we want to increase. So it means our current should be also this side, because decreasing to increase we should add. We should add means our field applied should be on this side. So our current will be anti-clockwise. So current will be anti-clockwise. Whenever decreasing, flux is decreasing, then we have to add. Add means same direction. When this flux was increasing, when suppose in this question we go from 0 degree to this side, it was decreasing. Whenever angle is this side, second quadrant, it will decrease. When it will increase, when it will increases, it means we have to oppose. So we will apply the field in opposite direction. So current will be, in that case it will be clockwise. But in this case, flux is decreasing, so we will apply the direction of induced current. Induced current will be developed in such a direction that magnetic field comes upward. So this is the direction. E is equal to phi I minus phi. Then I will be E divided by R. So you can practice such type of numericals. Taking the direction inward also you can practice, and taking different angles you can practice. If angle is different, flux change will be positive, negative, sometime decreasing, sometime increasing, and changing this original field also you can practice numericals. Changing the radius of the coil, by changing the radius you will change the area of the coil, that also can be practiced. And by giving different angle rotation, these can be practiced. So in the next class we will start new topic, that is motional EMF. In next class we will start new topic, motional EMF. But you must revise this is the base, Faraday's law of electromagnetic induction, magnetic flux. This must be quite clear to you, then only you can understand other concepts like self-induction, mutual induction, transformer. But magnetic flux, Lenge's law, Faraday's law, they must be very clear, and you must be clear about the directions also. Okay.